Are we back?
Yes, I guess so.
Yes.
Okay, let's continue. So the next thing is, let me share. The next thing is to do the actual forecasting. And so obviously we cannot use, we want to, no, where, sorry. Um, we have been, considered a way to select models based on some information criteria, and then as information criteria, when we use them, we can select the model which is the best on our full data set. And then as new data arrives, we can try forecasting using this new data. Another way to select the best model is to check its performance on the part of the data set. So for that, we would split our data set into train and test. Then we would check several models, how they perform on we train them on train data set and then check their performance on the test data set. And then we can select the model that is the best on the test data set. The usual, so here we are dealing with quarterly data. Usually in macroeconomics, so in economics in general, a sensible time horizon to forecast is 2 years. So, I'm sorry, we can consider basically, so we have our, 1 second, we have our uh, data frame view, and we can
Excuse me.
split it. Sorry?
Shouldn't we consider the forecasting period based on the number of observation in our dataset? Like,
Uh, yeah, so the thing is that you can, so we have, say, what is the amount? We have 90 observations. So suppose you use the first 60 to train the first model, then it's still what you can do with this. You can use this model to predict 1 to 4 periods ahead, maybe only 1 period ahead, and then increase the samples, include that period into the sample, train the model on the new sample, predict it 1 more period, and continue doing like this, collecting your error of prediction. That is something which is called the rolling forecast. And then you can compare models that uh, perform best in terms of this rolling forecast. This is one way to do it. And I would say that conceptually, this is perhaps a very good way to do it. But so it's in this sense that where you take the more data you have, the sorry, how should I say it? You adjust your forecast to the amount of data that you have in this way, but you don't necessarily change the horizon of the forecast. Usually, we don't believe these models to be good, reduced form models to be good for the prediction forecasting of many periods ahead. because we think about this whole structure as well, let me see. The thing is that, yeah, I'm a bit maybe jumping around. So um, eventually we are going to work with the time series, with the dynamic models. And then what I said is correct. Now, if it were a truly cross-section data, then we could have been splitting the data set like 60%, 40%, and then using the 60% of the data set to train our model and then see how it performs on the 40%, or maybe 70 to 30 or 80 to 20. The problem was doing this on what we have with the time series, even though we haven't considered the dynamic models yet. So we are just using like in essence the panel model, but it's not a dynamic model. No, not a panel. We lump all the time periods together, and of course, what we are doing here is not right because errors are obviously correlated because it's a time series data, and that's why we need to consider dynamic models. But anyway, we cannot. It's not a good idea even with this data. What I'm trying to say is that it's even worse to try to use this data and split it randomly into like 60, 40 or 70, 30%. Does this make sense what I'm trying to say?
Yes, just some additional question in this context. So you're basically talking about in sample training, as I get it, and testing. But why do we need it in the context of OLS? It's like we have those criteria, and OLS can't really predict anything, right? So it can just show you the coefficient. So why?
Uh, Wait, why do you say that OLS cannot predict anything?
Mm, because it is mainly used, well, I guess for causal causes. It's like
Mhm.
it.
No, this is the whole point of what we are trying to do. OLS is that's why I kept stressing that you shouldn't be confused. OLS as a tool is a tool both to do the inference, but also fitting a model to the data. And these are related but separate things. Logically, you can come up with any model, and OLS is just one example of a model to fit to your data or train on your data and then use that model to do forecasts. Then that can be any model. It can be OLS, it can be some nonlinear model like k-nearest neighbors, neural network. It's all variants of examples of different models that we can train on the data and use for forecasting. Now, in econometrics, we don't use models for forecasting, we use models for inference. We want to fit the right model, we still want to fit the right model to the data, but then our final goal is finding causal relationships with the right, in the context of a right model, while in the context of machine learning, we are not concerned with causal relationship. We don't care about the true value of this coefficient. If this is a true value or not true value, we don't care about this. Everything we care about is how well our model forecasts the future, giving some loss function. So let me get to that. Or maybe you want to ask something else?
Yes, now I got your idea. Thanks.
Okay, let me now get to forecasting. So uh, if we were, again, let me just, one way to do forecasting on, say, sorry, I will just bring some code that I have from the past. So I'm going to learn I didn't want to do it, but let me do it. I'm going to load from this model selection sk learn train test split function. And what I'm going to do now, I'm going to, if let's see if this would work. Let me see. I guess we need to do it. Mm, mm, oops. No. Let's see if this works. Okay, it works. Okay. So this is how you would deal. Let me see. Let me write this. Uh, text with power over this section. I would, so if we were dealing with truly cross-sectional data with no relationship. We know that there is a relationship, so this is the wrong way to do it. But imagine for a second that there were no cross-sectional dynamic relationship in our data. Then we would have split it randomly into two subsamples, the train sample of psi 80% and test sample of, sorry, here, let's say test size 20%, yeah. Then what we would have done, then say linear more, I haven't loaded this. Let me load linear model from here. So I will use a different OLS. Linear regression. I guess I also need to add, let me, let's see, it's, audio. I always forget. Uh-huh. Not constant. Linear model escalate. Fit intercept. Okay. And then say oops, and actually, uh, I can see the coefficient of intercepts, but one second, I need to load mean squared there.
So now we are fitting the model by our train sample and trying to predict something and check it on test sample,
Yeah.
right? Okay.
So I'm just trying. SK, what I'm doing here. SK means content. Metrics. Okay. I'm just demonstrating how you would do this in cross section, and just to show you that you just fit a linear model, and obviously then you can just calculate its mean squared error. Why test y test hat, then you can do another model, say on the same sample. Now you could say maybe extend to instance to um so say 0, 1, 2, 3. Oops.
What are you trying to do now?
I want to check a different model. What mean square this different model would give me? No, didn't work. X-train, let me see. Oops, like this. Okay, so now this is, you see, I used a different model, which contains only one predictor. Basically, I selected from this X variable only the IPI, the third column, and I used only the third column to do to train the model. So I used only this, and then I used this model to do the prediction, and then compared it in terms of mean squared error on the rest of the test data set, and it gave me a larger mean squared error.
So
So
it coincides with our AIC and BIC values, right?
no, this is okay. This is, first of all, what I'm doing. I want to emphasize that what I'm doing, uh, it will be only appropriate if the data was not dynamic. So let's settle this. It's not the right way to do for the dynamic data, and we are going to get in a second to the right way to do it for the dynamic data. But suppose this data was cross-sectional, then uh, when we were doing this Akaikyo Bayesian information criteria, we were training the model on the whole data set, and then we were using this magic information criteria to check the quality of the model. Now, or the informativeness of the model. And then based on this information criteria, we would select the best model. Now, here I'm trying to do something different. I'm dividing randomly my sample into two subsamples, train and test. I don't use any information from the test. I leave it aside. I use only the train sample to train my model. And then I check how that model performs on the test part of the sample by using X to predict Y, and then check the squared error, which, by the way, we will be doing for some time. We will be using squared error, while from the first lecture, you know that that's not the only way. You can do many loss functions. Anyway, now what I did next, I used a different model with only IPI as a regressor. I trained that model here, and then I used it to check how it performs on the test data set. And the now we can compare this number and this number. And here mean squared error is lower than here. So this exercise tells us that perhaps this model is better.
So for our purpose of forecasting, the first model is better, but when we build those models well, not fitted them, just build them based on the whole data set, the second model was better, right?
Yeah.
Yeah, okay. I see now.
Uh, right. But so the one thing that you should keep in mind when we are doing this is that I just want to say that usually you should aspire to in let me yeah, what I'm trying to say, I'm trying jumping ahead of myself at this point. I want to say that as a perhaps practitioner of this like machine learning forecasting prediction, you should prefer this approach, train tests split training testing on the remaining on the test part, to the information criteria, because information criteria are built on a bunch of strong assumptions, and they don't always work well. But it's not to say that this also works well. Of course, forecasting is a shaky business. Something you can forecast well, something you can't forecast well. But we are going to devote whole session or lecture, I will see, what's the best fit for it, where we will go deep into the information criteria so that you understand when you can trust them and how you can trust, in what sense you can trust them. But you need to understand this because they're so ubiquitous in the choice of dynamic models. Because there, when you're just trying to choose the best dynamic models, the best dynamic model, sorry, you don't have, very often you don't have enough time periods to do this kind of test and split. Anyway, let us now do something. Where was it? But our data, you know. So what we did is wrong. Instead, what we should do, we should do something different. Uh, 1 second. Let's say, um, actually, no. Let me think. I want to do the rolling forecast. Um, let me. let's say we start with 60 periods. So we start with the data set of 50 periods, and let me again do this. Now we can,
How many periods do we have in total?
90.
Okay, so it's like two-thirds of our sample is going to be the train sample, right?
Yeah, but you will see in a second. Not exactly. You will see in a second. Transfers, okay. Okay. Um, hmm, yeah. So what I want to do here, I want to do a rolling forecast. Yeah, let me do it this way. Actually, like this.
Why do we need a loop?
Uh, I want to do a rolling forecast. You will see in a second. Um, actually, okay, I can do this. So I use only part, the first train, whatever, the first so many observations. I fit the model to this first like 60, 61, 62, and so on observations. Then I use X, the next one to see how it fits. the next one, and then I what's going on? Too many.
Could you please explain the syntaxes of X train and Y train? Why do they have like different one?
So Y is let's see. Y is just an array. If you will, it's just an array with 91 values.
Yes, okay. So it's our dependent variable.
Yeah, dependent variable. X is an independent variable. Now,
Yeah, okay. I see.
if we say do this, then we take the first 5 rows of X and all columns from X.
Yes.
So that's what I was trying to achieve here. Sorry, this is the mistake. So that's what I was trying to achieve. I'm going in this loop and I'm adding one observation at a time. And then I'm trying to predict the next period value using the sample with like 60 values, then 61 values, and so on. Let's see. Shape your data using the shape. Let's see what's going on. Okay, maybe shape. Always say you could do one point. Does it work? Okay. So okay. What we did here, we ran our model, like whatever, estimated it like about 30 times, and used each time the values from the previous 60, 61, 62, 63, and so on. observations to predict the next period observation. And so what we can do now, we can add them all up and say, um, um, let me do this. Something is wrong. Okay. So now we can repeat this exercise for a model. So I don't need actually this part, and I don't need this part.
So how did we aggregate the array of MSE?
So you see, here I was calculating for the one period ahead forecast. I was calculating the squared error. Then I was adding all the squared errors. And mean squared error, what I'm doing. Say,
Because as I comprehend it now, you just put like the last value of cell, and that's it.
yeah, no, wait, here I'm adding them. I'm adding them up.
Yeah, okay, so it's like some kind of accumulative.
Yeah.
Okay.
Maybe let me do it this way. And okay, now we have truly mean squared error. It doesn't matter much, but anyway. Let me now say if we do it with a model that has only the force, the force column.
So we are not taking all our independent variables but one, right?
Yeah, now we are trying to use a different specification. The specification was only force column. So here we saw that this one was the best, and that was one way to check. And now we can just take any specification that we checked here, and then use this kind of approach of rolling forecast to check how like the different models perform on forecasting one period ahead forecasts.
And just to make sure, so during our time series course, we discussed rolling window, but as I get it here, we deal with the panel, so it's not really this kind of
So,
task, right?
right, I'm not, you see, I'm not really um, it's not a panel, first of all. It's rather, if you want to speak it in in these terms, it's uh, still like for each time period, we have only one set of observations for each variable. So in that sense, it's not the panel.
Why?
Uh,
Like
and
t periods and n observations in each period. Well,
no, we have only one observation for each period.
ah, yeah, okay. So it's a time series? No.
Yeah, it's time series, but it's time series with obviously it's time series because it's time series. What makes time series? It's correlation of errors. Uh, but we forget about correlation of errors for the time being. And then what we are doing here, we are not running any dynamic model, like not an autoregressive process, nothing like that. We do the forecasts for just using, again, 10 periods, like say, estimate the model on 60 periods, predict the next period, right? Then increase it, estimate the amount of periods estimated on 61 periods, predict one period ahead, and so on. Does this make sense?
Yes, it does. It still seems to me that it's a panel because we observe several variables in time. But okay.
Yeah, 1 second. Um, what's going on here? Um, so, okay, it's not, this model has a smaller mean squared error, but anyway, you see, it's not, again, it doesn't matter. If you want to call it panel, let it be panel, but it's not a panel. But it doesn't really matter, and that's not the point. The point is that what I'm trying to do here. And so let me just maybe perhaps um, do the following. Mm, no. Okay. Let's see. Oh, okay, let me not get into it. I wanted to plot how it looks, but anyway, man, what I was trying to say is that this is perhaps the right way to start thinking about how to do the forecasting with time series data. And here we were using a 1 period ahead forecast. Another, uh, you can change this and say change it to 2 period ahead forecast. Say we can complicate this code and say, oops, uh, make it 2 periods. I guess that would be 1. So we need to forecast horizon is 1. Right. This is the way to do it. And then no. Sorry. Okay. So we can do 2 periods ahead forecast. And then we can be accumulating the same errors. Let's say then the right way here would be uh, so if this is error, then like this. Does it make sense what I did here? Is
So
anybody still on? Yeah.
yes, we're still alive, I hope. So you just repeated the same model, but for like two-period forecasting, right?
Yeah, 2 period ahead forecast. And but again, the same idea, and you can do like I don't know.
Yes,
So that would
like
be two
5, 10.
models.
Yes.
Yeah. Let me see what I'm doing. Cannot reshape array to shape.
And
Origin.
just yes, to make sure, there is no strict rule like what horizon to use, right?
Yeah, exactly. And so here that was a trying. So this would be the right way to start doing forecasts with uh, time series data. So first, the big distinction is that in the cross section, you randomly were dividing the sample into a train and test. In the time series, when you deal with time series, you keep adding the values. Another way to do this would be to do just one time forecast. Like, for example, you can take, uh, so we have 90 observations, 90 time periods. You can take, say, 86 periods to train your model forecast for 4 periods for the 4 remaining periods, and then compare your models, how they perform on the only the 4 periods, the very last 4 periods, and select the one that's the best. What's wrong with that approach is that obviously you have only like 4 periods to check the performance of the model, but uh, more fundamentally, or maybe why having just a few models, few periods to make the prediction and then make the selection based on the prediction for the few periods is because you always have some error in your model, you have some shocks in your data, and you always have some unexplainable part of your data. You will, unless you're in some ideal world, which you're not, you will always have something that you cannot explain. And what you should aspire with forecasts is to be good on average. And this kind of rolling forecasting tells you take just one model and you're checking how that model performs on average on this forecasting it using the same model, fitting in different data sets or slightly different data sets, and using it to forecast again and again a little bit ahead, and then averaging everything. And that gives you an idea how your model performs on average through like many trials. And that is more analogous with this approach. And another way you might think about doing forecast, you might say, okay, let's take 60 periods of the data, train the model on these 60 periods, and then use the model to predict for 30 periods ahead. The problem with this is that we believe that with time series, this doesn't work. Because for one thing, is usually there is a dynamic component in time series that we will add as a next exercise, I guess not today, but next time. And so that's why we don't, in time series, we don't do forecast for like 30 periods ahead. We do this kind of rolling forecast. Does this make sense?
Yes, it does. But just to note that actually in cross section we can try to do, well, not the roll-in, but We can try to use how is it called?
Simple, similar idea.
Yes, it is.
Cross validation.
Yes, exactly. Cross validation. It
Exactly. And this is in a way, this is kind of a cross validation for except for it's not, because in cross validation
we
uh,
doesn't account for the well time series structure. So no correlation is.
yeah, but there is another difference from the cross section is that in the cross section our sample size across different cross sections is different, is the same. Here we keep changing the size, but we don't have to. And there's another, so this is actually, it's not a rolling window, sorry. This is an expanding window forecast where we keep changing the sample size. But we can go with the uh, rolling window forecast where we will be dropping the observations from the tail as we are moving. And then that would more correspond to the cross validation across section.
Yes.
Okay.
Yes. Okay.
Yeah, let me see what's, I think it has to be, no, what's going on here? Forecast horizon 4. Ah, of course. Okay, now it works. And then, yeah, the same deal, we can compare it with the other model. Okay, you can experiment with this. I got my point across. I will drop more stuff into the notebooks. I will drop the graphs. Um, okay, we have like 10 minutes left. Yeah, I guess we cannot start the time series, but the point was that we can actually quickly I guess no, let me leave time series for the next time. I guess we can finish here. Uh,
And talking about cross validation. So here, uh, can we do mm, divide our sample well by periods, like make 5 or 8 periods, and just build a model like on the n minus one of them and test on the nth one, and like that. So I know it works in cross validation, but in this structure, when we account for periods, does it work or not?
uh, so say it again. How do you want to do it?
Give me a second. Uh, can I draw something in Zoom?
Yeah, sure. 1 second. Um, okay.
Like here, right?
Mm-hmm.
So let's imagine that it's a cross section.
Mm-hmm.
We have some data. We just randomly divide it. So we have four groups, and after that we build a model, let's say on the first three of them, and test them on the. After that, we build a model like on the first, second, and fourth, and tests
Mhm.
them on the third, and so
Right. Yeah. Not build, but train. The
yes, well,
terminology.
yes,
Yeah.
train.
Okay.
But as I get it, if we think of this division like periods, we can do this technically, like divided by groups, but that doesn't make any sense, right?
Right.
Because it's strange to like train the model on the data of.
On the future and use it to forecast the
Yes, yes,
past. Yes.
yes. So
Yeah.
it doesn't work here, right? Yeah,
Yeah.
okay.
It doesn't exactly work, but it can work under some assumptions. For example, suppose one situation where it could potentially work is if you have a huge time series, like suppose you have daily values of some stock and you have like 30 years of observation, then you would have like what 9,000 of observations. Then supposedly, if the stock always follows the same model, then supposedly, like first 100 observations, they are not really related to the like last 100 observations, and so on. And so potentially, you can divide your data into the blocks in this situation, and then you can explore this idea. So people do this when you there is a reason to believe that after some time there is not much dependence between the blocks of the data, and so then if the model stays the same, then you can use later models to date periods to train your model to see how it predicts the first periods.
But only assuming some high frequency data and like much of it.
It's not necessarily high frequency, but it's usually the high frequency data where we have most of the lots of observations.
Okay, thanks.
Yeah. Okay. Yeah. Sorry. So, do you had a time series course, right?
Yes, it wasn't really how to say strong one, but yes, we had one. So we know how to, well, how ARIMA works, how to predict it. Yeah, so we know this stuff, but we are a little bit weak on Garch or something like that. We didn't have time to master them.
What about vector autoregressions?
It's like when you take several time series and make like I don't know, a pack of them, right?
Yeah, yeah. Like auto, it's basically AR process, but vector AR process. Did you work with them during
We
your course?
we discussed it, but like the last topic and just the preview of it. So we didn't actually build it. We just discussed some article which used it. So like
Oh, I see.
yeah.
Okay, okay, got it. Okay, then definitely that was one of the next things that I was going to introduce because there are some uh, problem sets that I want to give based on that. All right, then I guess it would be it for today. And the last thing, what do you usually do during tutorials and other, like in your machine learning class? Like what I was doing, is it what you don't want? Why there are only like two of you? People
Uh,
don't want? Is it too slow, too hard? It's not what you want to learn?
I guess exactly today it wasn't like the format of something. It was just that, for example, now one of our group is having another class, just like at the same time, and
Mm-hmm.
another group, it well we were told that we need to go to university, like there will be a class like with computers, but like this night you wrote us that we'll have it online, and some of us don't have like laptops. Yeah, so it's just the
Oh, but
yes.
how did you survive during the lockdowns?
Mm, well, some of us have like stationary personal computers, like that.
But wait, but I don't understand. It's like say, you come to, I see. You mean people didn't check emails, they woke up, they went to the school, and then they realized that
No,
it would
no,
be
no. So even if they checked your message, you see, in half an hour we'll have another class, and it's like offline in the university. So we can't get in half an
ah,
hour like from home to the university. It's impossible.
I got it.
Yes,
Ah,
that was the main problem why we were so worried about like having an online class this weekend, because we have like offline classes just after that.
okay, I'm sorry about
Yeah,
that.
that's the problem.
I see. Okay, I mean, it's just the thing is that I was sick and I was busy and I didn't prepare notes for Victoria, and so then she couldn't teach because I didn't. I told her what she could teach, but she said that she needs more time to prepare, and so I took it from her. But okay, hopefully from the next week it will be more stable. She will teach it.
Yes, I hope so as well. Mm, Last week we just didn't have any offline classes, so everyone
Ah,
who wanted, they just visited your classes. But this week it's like emergency situation in this sense.
okay, I got it. Well, okay. Hopefully it's not so bad. I mean, I will get, we still have some time to teach and learn. Okay, yeah, thanks for coming. Um,
Thank you too. It was pretty interesting and interactive.
mm, thank you, bye.
Goodbye.
Bye.